Today is the day that your life will change. We are going to graph ax plus by equals c. Here's your journal choice. This section is usually entertaining for kids because you will graph differently than I will or differently than your friends, and it'll all be okay. Come up with a method that works for you and stick with it. It's going to be in standard form, ax plus by equals c, and we're going to look at the graphs of them today. You have to be skilled graphers because they help us see trends and make predictions. Not only that, but you're going to be graphing forever and ever, especially once you get into calculus. It feels like you're graphing all the time in there. So make sure you know what you're doing. Standard form of an equation of a line. We talked about this already some. Ax plus by equals c, where a and b can't be 0, or both can't be 0. One of them can, but both of them can't be. And actually a and b are usually going to be integers. Okay, this is definitely going to be a line if it's in this form, and if b does not equal 0, so if we're talking about a function, if b is not 0, we're talking about a function, then you can have this. Your slope will be negative a over b, and your y-intercept is going to be c over b. And I'm going to be 100% honest, I never have used this. I am super duper amazingly awesome at y equals mx plus b, and I'm super duper amazingly awesome at solving for y. So I almost always take my standard form and put it in slope-intercept form. Some of you might memorize this. Gold star to you. Good for you. I don't like to memorize things. I got a lot of stuff going on in this genius brain of mine. So I prefer to just stick with the one y equals mx plus b, but this is a shortcut if you want to. This is definitely not necessary to memorize this. Okay, we're going to graph this using its x and y intercepts. This is also a way I don't graph very often. Some of you will graph this way every time if it's in standard, and that's okay. For your y-intercept, you let x equal 0. For your x-intercept, you let y equal 0. So this is very easy to solve. When I'm looking for my y-intercept, I plug in 0 here for x. The reason it's so easy to solve, and you should see it right away, is, oh look, how nice, this all drops out. So I have negative 4y equals 24. Y equals negative 6. Remember, x was 0, so my y-intercept is 0, negative 6. Well, I can graph that over 0 down 6. 1, 2, 3, 4, 5, 6. There's a plot. Okay? X-intercept, plug y equals 0. Again, once y is 0, I have 3x minus 4 times 0 equals 24. Equally as easy, this drops out. 3x equals 24. Divide by 3, x equals 8. Remember, x equals 8 when y equals 0. So the ordered pair 8, 0 is on my graph. 1, 2, 3, 4, 5, 6, 7, 8. Here we go. Draw it straight. Oh yeah. Oh, that was a pretty good line actually. Just a little bump there. But not too bad for freehand. And I have graphed my line. Okay, some teachers want you to draw 3 points. I'm okay with 2 as long as it doesn't look super sloppy. This method will work. It is very quick whenever you have standard form. I'm going to show you the other method. It's not asking you to do this by any means, but probably the way I do it most times. In this case, I probably would use the intercepts because I noticed that 3 and 4 work out nicely with 24. But if not, we could have easily gone to slope-intercept form. Minus 3x, minus 3x. Negative 4y equals negative 3x plus 24. Divide everybody you know by negative 4. Okie dokie, artichoke. I get 3/4 x minus 6. Y-intercept is negative 6. We already said that. And my slope is positive 3/4. Up 3 over 4. 1, 2, 3. I can't even tell where my dot was before. Pretend that's good. You could have done it again and you would have ended up on your x-intercept. Also works. Your choice. Good times in Mathland. Okay. Sometimes, I wish this was nicer. Sometimes I hate the way things look. And I have to fix them. Like this. Okay. It's kind of slanted still. Pretend it's good. This time they're giving us a line. They're saying, hey, why don't you write the equation in standard form? Okay. You can go with the intercepts again. That's one option. Or you can do y equals mx plus b. I probably would do y equals mx plus b because I'm an mx plus b fool. Here's my b, -7. What is my slope? My slope is my rise over run. I find some nice little points here that work out nicely. Oh, here's one, and here's one. My rise is 7, my run is 3. I'm going downhill, so it's -7/3. Y equals -7/3 x minus 7. Okay, so I have to get x and y on the same side, so I add 7/3 x. I hope you guys don't write that down every time you do it, but sometimes I feel the need to for you. 7/3 x plus y equals -7. This doesn't look very nice because of this fraction. So what we do is we multiply both sides by 3, and we get 7x plus 3y equals -21. Okay? Questions on that? I don't know why I just asked you that because you can't even tell me. If you do, why don't you write it down? You can ask me tomorrow. We'll talk about it. Special lines, the special lines. That is your horizontal and vertical lines. Remember, this one is your vertical line because it is not a function. There is no slope. Do you remember this? Mrs. Fessler may have taught you this. What happens to Mo, the slope man, when he tries to walk the vertical line? He says, Mo. He says, he's always happy. He's falling. Oh, no. Why is he saying that? Because there's no slope. Okay, and he falls into pieces. Horizontal line, he could walk all day. So he's good to go. Not a problem there. Zero slope. Equivalent equations. What you will find today when you're doing your homework is that some of your answers might look different than your neighbors because there are multiple ways to write things in standard form. The only way you can really check to see if you all have the same answer is to get it y by itself and then compare. Because like back here, the 7x plus 3y equals 21. That's the same thing as 14 plus 6x equals -42. I can multiply everything by 2. See, they look different. But if I got y all by itself, everybody's will look like that. Okay, so that's something to think about. Graph the line with this equation. Well, 0x plus 4y equals 14 is the same thing as 4y equals 14. Divide by 4, divide by 4, which is the same thing as y equals 7/2, or y equals 3.5. Okay, I probably would have just said y equals 3.5. Where does y equal? Oops, just kidding. 3.5 equals right here. This is going to be a special line of the horizontal variety. There we are. The other way you could do it is find two ordered pairs that satisfy the equation. I like if x is 1, then I get 4y equals 14. Y will be, guess what, 3.5. If x is 2, oh, still get 4y equals 14. Guess what? Y equals 3.5. Bottom will all be around here. Compute the slope of this line. Once you look at it, you know it's 0, but why? Because slope formula, y2 minus y1 over x2 minus x1. 3.5 minus 3.5, 2 minus 1, 0 over 1 equals 0. Okay, Mallory. She combines n liters of a solution that is 3 moles per liter with y liters of a solution that is 5 moles per chlorine. She ends up with a mixture that contains 2 moles of chlorine. Okay, this is a linear combination, so she has 3n plus 5y, and it will equal 2. They want us to graph this by finding the n and y intercepts. Okay, the n and y intercepts, you let y equal 0 and n equals 0. Let's go ahead and let n equal 0 first since it's on the left. Okay, if this is the case, I have 5y equals 2, y equals 2/5. When does it equal 2/5? It tells us here. N is going to be the independent, so that's the same as your x. 0, 2/5. wants what? Y equals 0. I get 3n plus 5 times 0 equals 2. 3n equals 2. N equals 2/3. 2/3 zeros on my graph. I could plot those points and graph them. After you graph them, use your graph to find how many liters of the 5 mole solution she must add 2.4 liters of the 3 mole solution to get the final mixture. Okay. Well, you'd have to accurately graph it first of all. Did I graph it over here? No. I know what to do. I'm going to draw this nice little graph paper. This is actually a pretty stupid problem for predicting things on a graph because those fractions make things not very accurate. Anytime you're using your graph to come up with a conclusion, make sure you have a really nice graph, and I'm not going to be able to give you one right here. I'd break out graph paper or use my graphic calculator, but you guys don't quite know how to do that yet without, we're going to talk about, I think, in 2 days. But let's go ahead and see what I can do here. I have 0 2/5. I'm going to go 5 dashes and make it 1. So I'm breaking it down by 0.2s here, okay? And I go over 0. Do this, that would be here. And then over 2/3. I don't know. About right? Yeah, that's bad. Okay, pretend it's not. And this was N. So it's Y. Okay, how many liters of the 5 mole solution? Which one's the 5 mole solution? N was 3. N was 3. And this one was the 5. Okay, they're saying if you have 0.4 liters of the 3 mole solution. So 0.4 was right here. Goes up to this spot. And you're looking at, I don't know, 0.1. It's hard to tell. Like I said, 0.1 mole. Oh, 0.1 liters. Don't want to do that either. 0.1 liters of 5 mole solution. It's hard to tell on this graph. If you had a graphing calculator, you'd get a real accurate answer back. Otherwise, what you could do is you have an equation here, guys. 3n plus 5y equals 2. They want to get 0.4 of the 3 mole liters. That's plug in 0.4 for n. It's 1.2 minus 1.2 minus 1.2. 5y equals 0.8. Oh, it would be cool if I had my calculator with me. It's so far away. Let's see if I can reach it. I have it. Okay. And I get 0.8 divided by 5. I said point. Oh, look, I'm smart. I got 0.16, and that's liters. So we were pretty good from our graph, even though our graph was not nice. If you had a graph paper, I think you would have got this right on. Okay. And there's a picture of Jackson. No, it's not really, but I always tell kids every year it's Jackson, and usually somebody believes me. Okay, have a good one. See ya.